Hi there and welcome to yet another video on DSA. In this video we are going to solve the range sum of BST problem on Leetcode. So let's go ahead and understand the problem first. So the problem says that given the root node of a binary search tree or BST and two integers low and high, return the sum of values of all nodes with a value in the inclusive range of low and high. So this is a problem where we have to calculate the sum of all the nodes which lie in this specific range, that is low and high, and this happens to be an inclusive range. What it means is that we have to consider both low and high as the part of the range only. So here an example is given where low is 7, high is 15. So we have to only consider nodes which are in this specific range, that is 7, 10 and 15. These three nodes are in this range and hence the output is 32. Okay, what else is given? There are some constraints also which are given to us, and one important thing here is that all the node values are unique, which has to be the case in, let's say, a BST, that all the nodes have to be unique. In order to solve this problem, we have discussed two important tree traversals. One was based on DFS, the other was based on BFS, and in this specific problem I'm planning to go ahead and use the DFS method. So we will simply do in order traversal here. And this happens to be one of those problems where traversal of the data structure can be used to solve the problem. So when we traverse the data structure, we actually go through each of the nodes and we can check whether the value of the node is in the range which we are looking for. And if that is the case, we can include it in the sum for the result, or we can simply say that we can include it in the sum. Now there is one more insight which is given to us. Given that it is a binary search tree, there is one thing which we have to keep in mind, and that is the BST property, which means that if we have already reached a node, let's say we have reached the node 5, given that this 5 value is already less than my low, I really don't have to go to any of the next nodes in the BST, because the BST property says that all the values in the LST are going to be less than this specific value. So this is another important insight which is given to us, and we have to keep it in mind while we are writing the code. So with all these things, let's go ahead and write the code for this problem. So let me go ahead and define a function which is, let's say, an internal function. I'm going to call it in order sum. I'm going to pass root to it, and like all the tree problems, if not root, we can simply say return 0. And now in order traversal says that first we have to traverse the left subtree, then we have to process the root, then we have to process the right subtree. So what is the condition we have to check here? We have to check the condition that if your root.val is greater than low, meaning that if the root.val, so let's say I am on this node, if this is greater than low, only then I have to move in the left direction, otherwise I have no need to move in the left direction. Also, let's have a variable to store the result. Let's call it result and initialize it with a value of 0. And now if the root.val is greater than low, only then I have to say that result plus equals in order sum root.left. So this will process my left subtree. The next thing is I have to process the root value. Now for the root value, the condition is very simple. That is, if low less than or equal to root.val less than or equal to high, only then I have to consider it for the result. So I can simply say result plus equals root.val. And similarly for the right subtree, I can simply say that if root.val is less than high, only then I have to go in the right subdirection. Or the right subtree, basically, not right subdirection. I can simply write in order sum, and here we will be writing root.right. So in this way we'll be able to calculate the sum considering only those values or only those nodes where the value lies in this specific range. So now we are ready to return the result. So we'll simply do this, and in the outer function, that is in the range sum BST, we will simply return a call to this function, that is in order sum, passing the root here. So now let's go ahead and let's run the code and let's see what the results are. Okay, so this is giving us the correct result in the sample test cases, and now we can submit the code and see. Okay, so this is interesting. We are able to beat 84 0.92% of the users, and in terms of memory we are taking slightly more memory, which of course we'll have to check what exactly is wrong with the memory here. So let me go ahead and see if there is anything which we can do about the memory which it is taking. So low is less than or equal to root dot value, less than equal. I think it's completely fine. Cool. So no, I would say no optimizations which are coming to my mind right now. But this is how you can solve this problem. This is how you can calculate the range sum of BST. Well, there are other methods also. For example, you can perform BFS based traversal also in order to solve this problem. You can try it out on your own, and you can comment and let me know if you want me to create a video on the BFS traversal as well. So with that, that's it for this video. I'll see you in the next one. Until then, take care and bye bye.